All right, let's dive into the mind of an AI. Ever wonder how it decides what to do, especially when it's facing a super smart opponent versus, just pure random chance? Well, it turns out it's a tale of two very different strategies. Okay, so here's how we're going to break this down. First, how does an AI even know what kind of game it's playing? Then, we'll meet our two players, the pessimist and the optimist. We'll get into the nitty-gritty of how they think, and then we'll make them face off. Alright, first things first, before an AI does anything, it has to figure out what it's up against. This is the most critical piece of the puzzle, right? Everything else builds on this one thing. And really, it all boils down to a simple difference. Look here. On one side, you've got something like tic-tac-toe. It's you versus me, head-to-head. A battle of wits where I'm actively trying to make you lose. But on the other side, we've got dice. There's no one to outsmart there. It's just chaos. Pure random chance. So here's the bottom line. Your entire game plan, your whole strategy hinges on that one question. Think about it. You wouldn't play chess with the same strategy you'd use to buy a lottery ticket, right? The AI has to know if it has an enemy or if there's no enemy at all. Okay, so now that we've got that down, let's talk strategy number one. This is the playbook for when you know you have a thinking opponent. Let's call it the pessimist's approach. It's basically built on one simple, kind of paranoid idea. Always expect the worst. This strategy has a name. It's called the minimax algorithm. And yeah, it is super paranoid. It looks at every move it could possibly make, and for each one, it thinks, okay, what's the absolute worst thing my opponent could do to me in return? Then, it picks the move where that worst thing is the least bad. It's the ultimate better safe than sorry game plan. And this is where minimax absolutely shines. In a game like chess or tic-tac-toe, where you can see the whole board, and you know your opponent's only goal is to make you lose, well, being a pessimist isn't just a good idea, it's the perfect strategy. Mathematically, it's the best you can do against a flawless opponent. But what happens when your opponent isn't some evil genius? What if you're not playing against a chess grandmaster, but just the universe itself? What do you do when the world is just plain random and unpredictable? Well, this is where our pessimistic friend Minimax starts to fall apart. See, always assuming the absolute worst is a terrible strategy here. Think about it. If you're rolling dice, the worst case is rolling a 1 every single time. But planning for that isn't going to help you win, is it? It's just not realistic. And this is where our second player enters the scene, the calculated optimist. This is the expectimax algorithm. Instead of constantly planning for disaster, expectimax plays the averages. It looks at all the random things that could happen and asks, which move gives me the best outcome on average? So how does that actually work? How do you play the averages? Let's pop the hood for a second and see what expectimax is actually doing behind the scenes. The core idea is actually pretty straightforward. For any random event, the AI figures out something called an expected value. It just takes the score of every possible outcome, multiplies it by the chance of it happening, and adds them all together. So, if there's a 50-50 shot of getting 10 points or losing 4 points, the average, or expected value, is a gain of 3. And it does this little calculation for every single point in its decision tree where things get random. It works its way backward from the future, and the path with the best average score, that highest expected value, just kind of bubbles up to the top. That becomes the move it makes. Okay, so you might remember that with Minimax, you can take shortcuts. You can prune the decision tree and just ignore paths that are clearly terrible. So the obvious question is, can we do that here? Can we speed up expectimax in the same way? And the answer is not really. To get a real honest-to-goodness average, you have to look at everything. You can't just snip off a branch because it's unlikely. Why? Because what if that super unlikely path leads to a massive game-winning jackpot? Even a tiny chance of a huge reward can totally change the average. All right, enough with the theory. Let's see how these two strategies actually perform. It's time for the ultimate showdown, Pac-Man. We're going to see what happens when our pessimist and our optimist go up against two kinds of ghosts, a super smart one and a totally random one. And wow, the results speak for themselves. Check out that first column. That's against the smart adversarial ghost. Our pessimist, the Minimax Pac-Man, wins 5 out of 5 times. The optimist, it gets absolutely destroyed. It just wasn't prepared for a ghost that was actively trying to hunt it down. But now, look what happens when the ghosts are just bouncing around randomly. They both win all their games, sure, but look at the scores. Our optimist, expectimax, comes out on top with a higher average score. Why? Because it's not afraid to take a few calculated risks. It sees opportunities that the super cautious pessimist would never go for, and in a random world, those risks pay off big time. So what's the big takeaway here? It's that using the wrong strategy for the situation is a recipe for disaster. If you're an optimist in a world full of sharks, you're going to get eaten. But if you're a pessimist in a world of opportunity, you're just going to sit in the corner and miss out on all the fun. And that really leaves us with a final thought, doesn't it? These AI strategies are kind of like reflections of us. Minimax is that little voice in our head that's terrified of losing. It's all about avoiding the worst-case scenario. And expectimax? That's our more logical side, trying to weigh the pros and cons, playing the odds like an investor. And maybe the most important lesson for both us and the AI is that the first step isn't choosing what to do, it's figuring out what kind of game you're actually playing. Because once you know that, everything else falls into place.